So, remember we're talking about the operations using algebra, right? So we've talked a little bit about combining, which is the operations of add or subtract, right? But you combine depending on the signs. We've looked at combining. Remember that in order to combine terms, they must be what kind of terms? Like terms, yes. So x squareds can be combined with other x squareds, y's with other y's, etc. So they have to have the same base and what's the second part? Exponent, base and exponent, in order to be able to combine them. Well, today what we're going to do is we're going to talk about multiplying terms. And it's different. Be sure that you always understand what operation you're dealing with so that you know what rules to use. So we're going to first just start talking about some steps to multiply algebraic terms. Remember that all you need to do is remember that every term has exactly how many parts? 4 parts. Good. So 4 parts. And so you're just going to deal with each one of those 4 parts individually. And that's true of every algebraic term and every operation. What's the first part of every term? There you go, the sign. They're either positive or negative. So remember that when you're multiplying, if the signs are the same, the answer is always a what? Positive. If the signs are different, the answer is always a what? Negative. Good. So sign rules for working with terms. What's the second part of every term? The coefficient. And remember that the coefficient for a term is simply the number part, right? So, and it is with any multiplication, all you're going to do is simply multiply the numbers. So determine the sign first and then multiply the numbers. So you're just taking it piece by piece. What's the third part of every term? Very well if you can't remember that. And what you're going to do is you're simply going to keep that base. It won't change when you multiply. Because the base is just what kind of object it is, right? And then finally, on every base, whether you see it or not, there is an exponent. And the exponents will change. Because if you think about it, exponents simply mean you're multiplying something times itself over and over again. Well, we're multiplying more, so our exponent is going to get bigger. So what we're going to do is we are going to add the exponents on like bases. So they have to have the same base, but if they have the same base, then you're simply going to add the exponents. Okay? And we'll talk about why in just a moment. So the first parts aren't that bad. We've done signs before, so you know how to work with signs. With multiply, you just have to make sure that you know it's multiplication, so you know to use the multiplication rules. Multiplying numbers, you've done 1,000,000 times, and you love to multiply numbers. And keeping the base, there's no work involved in that at all, so big deal. The part that looks a little different is adding the exponents on the like bases. Because there's nowhere in arithmetic where you would ever add an exponent. Because an exponent means multiplication. So I want to describe that a little bit before we go on and do some examples. So let's just say we have x to the third times x to the fifth. If I were to expand these, x to the third means x times itself how many times? 3 times. Times x to the fifth means that you have 5 x's multiplied together, right? And so if you expand that and then count how many x's there are, how many are there? 8 of them. So that gives you x to the 8th power. And if you'll look, you can get there a lot faster by simply adding the exponents. Okay? And so adding the exponents is just a shortcut because even just x to the third and x to the fifth, that took a bit of writing to get all of them out there, right? And so if you have x to the 12 times x to the 24, you don't want to have to write out 36 x's, then count them, and then rewrite it. So instead, we can use the shortcut of just adding the exponent. And it always works. Okay? So what if I have y to the third times y to the 6? Are the bases the same? Yes? So that just becomes y to the 3 plus 6, which is y to the what? 9th. Okay? Now again, you've got to be careful, and you have to memorize when. So you need to be studying these notes, because if you don't remember when to add the exponent, that's going to be a problem for you. And remember that the bulk of your study from now on, when you move to year 10 and beyond, the bulk of your study in mathematics is going to be about algebra. So if you don't have a good foundation now, it's going to come back to haunt you the whole time. So you simply have to memorize this. Okay? All right. So what we're going to do is we're just going to look at some algebraic terms today, and we're going to perform the operation of multiplying them. And we need to look at a lot of them, because you need to find out, you need to see the notations and see how these things work. Because multiplication in algebra can be written in lots of different ways, right? We talked about how you can use brackets sometimes, or symbols sometimes, or no symbol at all sometimes, etc. So let's just go to the book. Just a moment. Okay. So what operation is indicated here? Multiplication. Now, this one is not an algebraic term. Why is it not algebraic? There's no variable or no base. Yeah, there you go. Okay. But this one is algebraic. We can multiply any kinds of terms together. We're just going to follow that process. Okay? So they're both positive. So a positive times a positive is just going to stay a positive. And again, if you know that your sign rules are weak, write every sign, positive and negative, and always say it. Right here, now you would probably just want to say 5 times 4, but always do it in order. The first thing you should do is look at the signs, even if they're both positive. You need to get in the habit of thinking signs, because it's the number one mistake in algebra. Second thing we're going to do is we're going to multiply the coefficients, which just means multiply the number parts. Well, this is its own coefficient, so 5 times 4 is going to give you what? 20. Third thing we're going to do is keep the base. What's the base? The only base we have up there? K, so it's just going to stay K. And then we're going to add any exponents on like bases, but there's only one K there, isn't there? Is there another K we're multiplying with? So is its exponent going to change if I'm not multiplying it by anything? Nope. So there's your final answer. Okay? So now if the 5 had a K in it, then the exponents on the K's would change. But since the 5 didn't, the only thing I had to multiply with was just the number itself. Okay. Let's look at some others. Drop down to this one. We have 4x. Whoops, sorry. We have 4x times, I better write your x's weird. I can't stand it. I'm going to use the dot for multiply, but you can use whatever you want. Is that all right? 4x times 3x to the second times 2x. Do I need a new rule since I have 3 things multiplied together? Not at all. Okay? First of all, always identify the operation. What operation is indicated here? Multiplication. So I'm multiplying. Remember, I use the dot for multiply. Multiplication. So that means first I need to determine the what? Signs. Now I have 3 things multiplied together, but that's no big deal. I can determine the sign just by walking through each one of them. So the first one is a what sign? Second one is a, so a positive times a positive just stays a positive. And the third one is also a positive, so a positive times a positive is still a positive. In other words, they were all positive, so your answer's got to stay positive. There's no way it can become a negative, right? Then the second thing I'm going to do is multiply the coefficients, the number parts. So 4 times 3 is 12, times 2 is 24. Okay? Third thing I'm going to do is keep the base. What is the base in all of these? X. And finally, I'm going to do what to the exponents? Add the exponents. But I've got an issue here. The first x doesn't have an exponent. What does that mean? The exponent is a 1, exactly. Anytime you don't have an exponent, assume a 1. And if it helps to make it more visual, write those 1s because you're going to use them. So the first exponent is a 1. The second one is a 2. So 1 plus 2 makes 3, plus 1 more is 4. So my completed answer is 24x to the 4th power. Easy, 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 but you've got to memorize when to do this. Did we add the exponents when we were combining like terms? No. So you've got to remember and be careful that every operation has its own set of rules, right? Okay. Let's see what else they do to us. They put things in brackets, but that just means take the first thing in the bracket times the second thing in the bracket. Let's look at P. I'm going to change it slightly because I'm tired of all positives. So P, we have 9xy to the 3rd times 3x squared y. Let's make that a negative 9 just because it's boring otherwise. Okay? All right. What operation is indicated here? Multiplication. So, first thing I need to do is determine the what? Sign. It's a negative times a positive, which makes a negative. Okay? Second thing I'm going to do is multiply the coefficients. Coefficient of a term simply means the numbers. So it's 9 times 3, which is 27. Excellent. Okay? Then, the next part is to keep the base. But what do you notice about these? There's 2 bases, aren't there? Okay? So I need to do each one independently. So first I'll work with the x's. So I'll keep the x. And what do I do to the exponents? Add them. So the exponents on this first x is a what? A 1. On the second one it's a 2. So 1 plus 2 is 3. So I get x to the 3rd. Now I'll work on the second base. So you can't have more letters, just think of them independently. So y to the 3 plus what?
1.
Plus 1. Be careful, okay? So that gives you y to the 4th. So you can add the exponents on like bases. So be careful. So say you have 3x times 4y. Positive times a positive is positive. 3 times 4 is 12. But are these like bases? Nope. So I'm just going to get xy. I can't add any exponents because they're not both x terms, right? So you just get an x and a y. So be careful if you don't have like bases, you can't add the exponents. Okay. All right, let's go back to the book to see what else. That looks like it. So we're going to do exercise 4F. Now, it is up here, but I need for you to be checking your answers. So I want you to use your own snowflakes. So I'm about to take this down because I want you to check your answers as you go. And it's super easy. Just do number 1, click that button and see if you got number 1 right. Click that back and go back and do number 2. Check your answers as you go. If you have done this entire exercise and you don't have them right, all you've done is taught yourself how to do it wrong. And then you'll do it wrong forever. Okay? So make sure that you're checking your answers as you go.